Okay, and now we're going to get into the fuel system on this vehicle. All right, so this is used as direct injection with the high pressure pumps. I don't know how they are on the other manufacturers. It totally sucks on these things. That's the biggest fail point on this engine, is the high pressure system. A lot of times these engines run loud to begin with. If you have excessive noise or it sounds louder than normal, if you take a stethoscope, just put it down in this area of the block, that's where your high pressure pumps are. That's where your noise is coming from. If it sounds louder, you're selling them in pairs. A lot of times on these engines, you're going to see random misfire faults. Loves to throw random misfires, and you may not feel anything or may run pretty much smooth. The biggest issue with all of that is your fuel octane rating. Rover recommends 93, but you can get away with 87, 89 once in a blue moon. Again, this all comes back to the third owner. If they're running regular fuel in this thing, it's going to screw this engine up like you wouldn't believe. Usually if you get a random miss, best thing, what they recommend doing is go in there, dump a high quality fuel injection service in the tank. The best thing we used to use was the BG44K. This was actually had a hard misfire, a random misfire in it. You can see half the bottle is water in it. They just got bad fuel. But when it comes to your misfires and everything else, you still gotta rule out the basics on it. Not everything's going to be a component failure. It could just be that the customer is cheap. Okay, and the benefits of why we all went to direct injection and all. Better fuel economy, reliability and all. Okay, the low pressure sensor. So when you're going to end up having two fault codes on them for a fuel system fault. However, the most common one is going to be a high rail pressure sensor, and it will just flag it as a low fuel pressure. It doesn't go into detail on high or low. The one thing you want to always rule out is what your fuel pressures actually are. Like Josh was saying before, a lot of times you go in there, have high pressure pump faults, you have a faulty low pressure sensor. So when it comes to the fuel pressure issues, when it comes into your sensor readings, Rover has specs that should be what it should be, and then there's real world specs, and we'll get into them. The way it works is your best friend on any of these, if you have an issue and you just want to compare your data PIDs, is if you have another vehicle or a known good vehicle and you compare it to that vehicle. That's the only way you're going to get a somewhat of an accurate reading. So you have your lift pump, which is your in-tank fuel pump. That sensor monitors your in-tank fuel pressure. That's a low. So that's your low pressure sensor. If you go in with the Autologic, it's what's going to be listed as your fuel rail pressure low B. So this is the location of it. This is probably the only picture in the world of where it actually is. All data, everyone else, nobody has it. Even in Rover's manual, it does not exist. What you're going to see in the real world when you go to it, it's going to have an aluminum heat shield covering it. But that's where the sensor is located, on the right side of the transmission. Now that's on an LR4 in a Sport. The full-size Range Rover, I believe, is in the wheel well on that one, and that's on the driver's side, right? Driver's side wheel well on that one. All right, our low pressure system is, Rover says it should be 4 bar, 65 PSI. Now, realistically, that's not what you see when you go in there. What you typically see if you go and read it, the way you'd want to test it is you want to go into the vehicle, do key on, engine off pressure. Or basically when you get to the vehicle, if you open the driver's door, it primes your low pressure system before starting. The idea of that is it's going to give you maximum fuel pressure. When you take a look at your maximum fuel pressure, it should be 105 psi. So that you're going to see your low fuel pressure B, and that should be at 105 psi. Once you start the vehicle, it's going to be on your high idle for a little bit. It's going to stay at that 105. Then all of a sudden, the engine RPM is going to drop down. When it drops down, your low pressure should be basically 79 psi is what you're going to see across the board. Now, they're saying 65. Out of everyone I've checked so far and dealt with, not 79 seems to be the magic number. After warm up. But yes, it can go as low as 65. So if you're seeing anything lower than 65 psi, you either have one of two issues then. Either you have a weak low pressure pump, or we can't trust our sensor. Now our sensor itself, if you look at your PID data, if you look at your voltages on that sensor, if it's stuck around 4 volts to 4.7 volts and it's stuck there, that's an internally shorted sensor. Yeah, basically 4 volts or higher. It's a 5 volt sensor, so if you're at 4 or higher, it's a shorted sensor. Ideally, you usually see, depending on what your pressure is, temperature, and everything else, it's usually anywhere between 0.8 of a volt to 2.5 is usually the ballpark range that you'll see. All you're really looking at really is when I give it gas or command different fuel pressures, is my voltage changing? If it's changing, okay, I think I have a good sensor then. This is where it comes into where we really don't know what the hell the data is supposed to be. All right, so even though everything looks right, as long as everything seems right, and if we're still suspecting a low pump issue, what we would do then is, or drivability issue, is you change the sensor. It's the cheapest part of it. You change the sensor, revisit it, and see where it goes. Okay, the other thing that can throw you for a loop too is your fuel pump driver module. That's usually when you're at wit's end, you've gone through the whole entire system, and now you still have low fuel pressure, it's acting erratic. It's usually ends up being the fuel pump driver module. All right, this on a full size range, this is your location of your fuel pump driver module. It's under the seat in that little nook over there. So that was the whole diagnostic of your low pressure issues on that part of it. Now moving into your high side where they really have the issues with the vehicle. These are your 2 high pressure pumps. They have your cam followers and they ride off its own cam. And we'll get into on how to check the quick and easy way to check timing on it if you don't have the tools. There's a few easy, quick ways of checking it if we think our timing's off. Now here on the block, you can see that's the actual location of it. I actually lost the cam follower. For my last course I went to, I have no idea where the hell it is. Some of them you will find when you change them, high pressure pumps, you may see the cam follower a little worn. They also have issues where, very few, where they may actually wear on the cam. So just always take it out, take a peek at it, see what it looks like. When you go to put them back in, anytime you're doing the high pressure pumps, you're changing the followers with it. The other thing that's a good idea to do is put a little bit of grease on the end of it, on the cap when you put it in. That'll help prolong the life of it a little bit. Other issues with the high pressure pumps, they internally leak. So if you're seeing rich faults, right, a lot of the times, which I wish I had a pump here to show you. The spring here in the plunger that's on the high pressure pump, the seals will leak on some of them. So why you're getting your rich fault is because your high pressure pump's leaking and it's putting it right into the oil in your block. The only way to catch it, because we don't have a dipstick, You can't smell it. You may get a little bit of odor. You know, if you go there, take your cap off, you might get a little whiff of it. Otherwise, it's pretty much change your oil. You change the engine oil, take it for a ride, smell the oil as it comes out, reset your fault codes, take it for a ride, see if your rich fault goes away. If it did, then we know we got fuel in the oil, and we're looking at high pressure pumps. Now, our high pressure pump itself, here it says it should be a perfect pump. Your PID data should be 2,175 PSI. All right, real world value is anything above 2,000 PSI is good. All right, so again, you can't be hung up so much on your PID data, what you're seeing. Anything higher than 2,000 is perfect. Now, what you're going to see is, to diagnose that one, is, again, you're going to have your cold start. When you first start the engine, you should have no lower than 2,000 PSI. And on the tool, that's going to be your fuel rail pressure. That's all it's going to tell you. So it's going to be 2,000 PSI. Once it kicks down off your high idle, it's going to usually level out at about 500 PSI. The next step you do is you bring the engine RPM up to 3,000 RPMs and hold it there. When you increase the engine RPM, you should see your high pressure actually increase up to that 2,000 PSI. Now, again, that's just a ballpark figure. Sometimes you compare it to another vehicle. Sometimes it's less and it runs absolutely great. Other times it doesn't get there and you have issues. None of it makes any sense. All right, your high pressure pumps, they're both identical. You have your left and your right. Your rear pump should be bank 1, your front pump should be bank 2. However, I know they had it wrong in the book and I don't remember if I fixed it or not. Best thing to do is follow your fuel line. If you have misfire faults on one bank, what they want you to do is replace all the injectors on that bank, along with it if we're suspecting fuel issues. Okay, fuel rail pressure high range sensor, that's this guy over here. Cold, you should see roughly between 3 to 0.15 volts. Hot, you should see about 2.3 volts. An internally shorted sensor is 4 volts or higher. Now, granted, it's a 5 volt reference, so anything from 4 to 5 volts is a shorted sensor. Now, this is, as you can see on that block, this is the location of your high pressure pumps. Again, I wish I had one to actually show you bolted to the engine. But that's your location of it. When you see it, you're gonna have your high pressure pumps, your fuel lines on it. It's gonna have the acoustic covers, so it's not as loud. All right, come back to your PID data that you were talking about before, Doug. When you come look at it, it's going to give you a duty ratio, and a lot of it is inaccurate. You know, some of it they use, some of it they don't. Here's your fuel rail sensor.
Is it inaccurate because?
What you can't, here's the whole thing with it.
Issue, or
no, you can't trust it. Let's put it this way. A lot of what you're seeing here, you really can't trust because everything relies on the sensor.
Yeah, exactly.
So if you have a bad sensor, everything's going to be off. You know, so this one's actually showing, I believe this is just showing at idle with a good sensor. This is actually a hot vehicle already running. If you look at your voltages, so here it would say fuel rail sensor high range, she's at 3.4, and then you have your low range sensor. Now, certain models, these screenshots come up differently than what it will on certain models. A supercharged one, which this one's off of, shows your readings totally different than a normally aspirated, just with how the layout is on it. I don't know why they couldn't get everything accurate, you know, just one setup. What you're looking at when you get into it is your On this one, your fuel rail pressure, where it just says your rail pressure, that's your high sensor. That's going to be your fuel pressure reading for your high. So what I was saying, your fuel rail pressure low, the way that's going to come up is fuel pump control B low pressure. That's why we just go by rule of thumb. Anything lower than 2,000 PSI on your high side on the cold start, or at 3,000 K, is anything lower than that is a faulty pumps. As long as we trust our sensors, everything relies on these sensors, which are garbage. But yes, in a perfect world, if you took STD's numbers and Autologic numbers, your readings would be identical. Now, the only difference is you'll find with the Autologic, it'll show extra PIDs that you won't get in the dealer's software because of a different variant on the engine. So a supercharged will use some data PIDs that a normally aspirated may not use. The only ones you're actually paying attention to is your fuel pump high, which is your fuel rail pressure, your high range voltage, your low range voltage, and your low side pressure. Those are the only ones that actually come in play when you're trying to diagnose it. And again, if you have a good vehicle in the shop, that's the best way to do it. Hook it up to a known good vehicle, take a picture of it, save it. Our fuel rail pressure, our fuel injectors itself, they are prone to leaking. Internal. What will end up happening is you may get a fault code for no fuel pressure when cranking at rail. What ends up happening is the fuel injectors will fail. They stick open. Usually you'll smell raw fuel coming out of the tailpipes, or a real strong fuel smell in the exhaust. They will fail to the point where you actually have fuel pouring out of the tailpipes while you're trying to crank it. I had one where it was enough to fill up a bucket while you're sitting there cranking the car. California has the same issues as we're having here. So you got the extreme heat and you got the cold weather. The random misfires seem to be affecting more in the colder climates than you have in the warmer with your random misfires. And it also depends on your fuel quality. Some parts of the country use more ethanol than others. That all plays in a factor of when your injectors fail, random misfire faults, and everything else that you have. Now, to get these injectors out, you will need a slide hammer to pull these things out. They do break easy. A lot of them are going to be stuck. Brake clean, or if you go in there with rust penetrant prior and just fill up the holes with rust penetrant, let it sit if you know you're going to go in there, then it'll come out a lot easier. Rule of thumb is if you got a bad injector, usually you're going to get a misfire on that bank or on that cylinder. If you're going in there to replace one injector, you're going to replace the whole bank. If you get the injectors from the dealer, they only sell them as a 4-pack. That's the only way you can get them. Aftermarket, you can pick and choose what you want. There is no coating or anything else with your injectors. You just take them out, put a new one in, you're done. All right, so the other issues you may have is a lot of times you end up with a fault code for too high a fuel pressure as well. Usually when you see that one, after you ruled everything out, meaning you already changed your low pressure sensor, you know your low pressure's perfect, right? You got 105 on a key on engine off, 79 at that's once it's idling. Your high pressure's still off. You have 2 new sensors in it. You know your low pressure's perfect. You either still have too high a fuel pressure or too low a fuel pressure. We already put new pressure, we already replaced the high pressure pumps in it because we found those could have been faulty. Then it comes into play, is there a high pressure pump cam off timing? Which doesn't happen often, but it will happen. Usually the telltale sign, it will sound like a timing chain rattle, but it's deeper in the block. And if once you heard one of them, you know exactly what that sound is. Now,
What's the drivability issue with this?
same, just a fuel-related lack of performance. Sometimes you might not have a performance issue, depending on how it jumped. Just a check engine light.
And it'll be higher than normal?
Usually if the chain jumps, you end up the fault code for too high a fuel pressure. It usually doesn't go too low, but it can go either or. Now this is the special service tool you need to make it easy to check your fuel timing. Now, a lot of you, unless you've gone in there and actually going in there to do your timing chains and everything else, you're not going to have it. This one I think was $35 off of eBay. That was about it. Anytime you're doing anything with these engines, you want the parts. Anytime you're getting involved with, if you're going to chains, tensioners, anything, do not go in there and start playing with it unless you actually have the tools. So get your special service tools. I mean, my whole kit here, this kit plus the timing tool for the high pressure pumps, I think was all on, the whole kit was under 200 bucks. This could happen anywhere between 15,000 miles to whenever.
20,000.
It doesn't matter. I've had injectors fail at 15. Actually, 10,000 miles I had injectors fail on me, where I was filling up a 5-gallon bucket with fuel coming out of the tailpipes.
And what about the chain?
The chain itself, they fail. Tensioners wear out on them as soon as 30,000 miles, they'll fail.
This is an oil, you think it's an oil-related issue or just quality?
No, this is just quality control. And we'll see once we get to it. There's nothing to it. There's no hydraulics or anything else to your high pressure chain. All right, this tool here, to install her, you are taking out your crank sensor, setting your engine to top dead center. And once it's set to top dead center, this will fit into your flywheel, which all you do is take out your crank sensor. She's going to drop right in there. There's a gap in there where the square will fit, so it's only going to fit in one spot only. Once it sits in that flywheel, that's what they consider your safe mode. So that's basically top dead center. Now, there is a quick, easy way of determining whether or not you have a high pressure pump that jump timing or not without having the tools before you get involved in it. Once everything's set up, you put your tool in, you peg everything. If you're taking it apart, if you're taking your crank pulley off of it, mark the location of it. Take a paint stick, mark it so you know where it goes back in and everything lines up.
It's not keyed?
It is keyed, but you want to make sure your timing stays where it needs to be. So if you take that tool out, unlock your flywheel or something, you want to make sure everything goes back the same way. So this is your vacuum pump that's on the front of the engine. Your vacuum pump bolts right here. So what you're going to do is you're going to go in there, you're going to set your safe mode, take your vacuum pump off, and then take a look at your cam. Depending on where your cam location is, will tell you real easy what you have going on. And here you can see a better picture. This is the actual vacuum pump bolted to the front of the engine. Remove the 2 bolts to hold that on. That will come off and give you access to the cam. It looks a lot easier than it really is because you got to take a bunch of crap off to get to it. Okay, this tool, the special service tool that they have for it. So if everything's perfect, in a perfect world, if it's set to top dead, you'd put that in, everything would be great. That should fit. All right. This one, my cam is actually off. What you'd want to do is make sure your keyway, if you have it stripped down like this, you can see your keyway. If you're doing your chains, your keyway needs to be at the 6 o'clock position. That's top dead. However, our high pressure pump is actually off because right now that tool should fit in it. So if you have the tool, it's the quick, easy way of doing it. You take your vacuum pump off, you know it's set up right, put it in the hole, it doesn't fit. One thing you don't want to do if your timing is off and you're trying to play with it and get it back, do not put a wrench on your crank and try to walk it back the other way. You're just going to screw your timing up even more. So take your time and actually just move your high pressure cam. Okay, so now the way of checking your timing without having the tool. So you still need to know where your top dead center is. Whether you have the peg to put in the crank sensor or not, or you take, if you don't have that, take number 1 spark plug out. On this engine, this is going to be your number 1 in the front here. Take your spark plug out, stick a screwdriver in it, whatever, crank it over till it's top dead. Now, if you can see it, try to look for the keyway on the crank if you can see it. Chances are you're not going to be able to, but the keyway needs to be in a 6 o'clock position. Here we have this one over here on our left. This is out of time, kind of like this one is. If you notice that big slot in the center, that's what your vacuum pump rides off of. Now, when you have that, if it's in time, that slot hole should line up with those bolt holes. So here's a closer version of it. Now, there's 2 different versions of that too. It can line up with it can still line up and be in time and line up with the bolt holes. But if you look at it, see where it says FOMOCO? That needs to be legible on top. So it would have to look just like it does in the screenshot. If it's not, your cam's 180 out. Or you're not on top dead center. And here's a picture of it actually set up. As you can see, that slot lines up with your bolt holes. So that's your timing's correct on the high pressure pump.
But on that one, you're 180 out.
Yes, exactly. I'm 180 out on this one.
Because the FOMOCO
is on the bottom. But our timing's correct for the spot, just that I'm 180 out.
That makes sense.
Now, you can't read it, but this is out of timing on the right-hand side, and this is actually lined up in time correctly. As you can see, the bolt hole, this big slot lines up almost perfectly with the bolt holes. That's the quickest way of going in there and seeing, without having any tools or anything else. You just go in there, pull your pump off, take a look at it. Now, if your chain is off, then we got to move our high pressure pump to get back in time. Now to do this, this whole front cover needs to come off, so you're stripping everything now. But as long as it's just out of time and we don't have a tension or a chain issue, this is all we need to do to it. Get it to where it looks just like this, then you can get in there.